Hi, so in this video, we are going to learn about CAP theorem. So before moving to the CAP theorem, we need to understand what does this initial stands for. So you see here stands for the consistency, A stands for ability, and P here stands for the partition tolerance. Okay, so let us understand these concepts one by one. So here we have a distributed system of consisting of three nodes here. So consistency means the system should always return in the latest information. Okay, all the time. It should not never return any stale information. So all the nodes here are in sync with each other. They carry the same information. Okay, it will never give you any stale information. If you are getting stale information, and that is not good for applications which requires which requires data which are critical for their business. For example, banking applications where you need to always get the latest bank balance. So that's where consistency comes into picture. Please make a note that client will always get the latest information here. Then we have availability. So a system always gives response. Okay, here even if the information is still. The basic idea here is that the all the nodes should be always up. It should never give. It should never be down. So for example, application like social media application like Instagram or Facebook, the availability there is very important. Even if you are getting stale information for a few seconds, it doesn't matter. That's where availability comes into picture. All the applications are up. They will all the clients will always get a response from at all the time. Next is partition tolerance. So a distributed system continues to operate. Even there is a network partition. Okay, even if network partition happens, that this node is not able to communicate with any other node, in that scenario also the system should be able to work. That is where CAP theorem comes into picture. So when such a situation arises, what decision we need to make, that is what we are going to discuss next. So in a distributed system, network failure happens, like a node may not be able to communicate with the other nodes. So there are many reasons for it. For example, it may due to network failure may happen due to node crash, or cables may break, or a cluster is split into groups. So CAP theorem states that a distributed system can provide only two of the following three guarantees. Okay, so, so in a distributed system, we cannot avoid partition tolerance. It is bound to happen. It is inevitable. So when a partition tolerance happens, we have to make a trade-off. So we have to decide whether we have to choose consistency or whether we have to choose availability. So either it is C, P, or either it is A and P. It cannot be CA, because we cannot avoid partition tolerance. That is what I'm trying to say. So you must choose between consistency and availability when a network partition happens. So let us understand what is this CP and AP are. Okay, so this is a diagram wherein in a real distributed system we need to make a trade-off when a network partition happens. Either you choose uh, CP, or you have to choose availability and network partition. So let us understand this AP system, that is availability and partition tolerance. So partition tolerance has happened. So you made a choice of being available. Okay. So in this scenario, if you can see that node A and B both are healthy, and in fact, all three are able to accept read and write. Okay. A is still connected to B, and B is also still connected to C. But the problem here is, since C is got out of sync, since C also is available here, the client can also write the data here. So it may happen that if C is accepting write, and if a client is writing some information in this node, A and B may go have the stale information. So there are chances that since all of them are available for read and write, and C also can able to accept write, it may happen that both these can go out of sync. That is what I mean to say. So it may not have the latest data from C. Similarly, B may not have the latest data from C. Okay, since anyways, if somebody writes to A and B, definitely this is not going to have any latest information from, if at all, if A is accepting read and write, and somebody makes a write entry here, and C may not have that information. So overall, in this system, all the three nodes are available for read and write. All of them are available. That's what we mean by availability. But Since one of them is out of sync, this system can have stale information. So as I mentioned here, since all of them are accepting read and write, the consistency may diverge. So they may get all the information in A and B can be stale because C is got out of sync. So let us discuss behavior in the CP system, where we have chosen consistency when a network partition has happened or a partition has happened. Okay, so here also CS is out of sync, but here we make a deliberate choice that we will not make any read and write. The clients will not be connected to this node. Only they will be connected to node A and B. And since both are communicating with each other, they are in sync. So both are accepting read and write, and they're still connected to each other. That means both of them will always have the latest information. They will always have the information which is consistent to each other. Since C is simply cut off from the writing, no client can read and write here. We made a deliberate choice here. So we'll always have the consistent data here. That's what we mean. Since A and B are only accepting read and write, so both of them will have the consistent data. Definitely it is not accepting read and write, so it will not be consistent. That is what we mean by a CP system. So what are the use cases here? So let's say we have made a choice of ability and partition tolerance, right? So where these systems are used, okay, user experience matters most than the correctness of the data. Okay, wherein temporary stale data is still acceptable to you, but here important thing here is the system must never go down. It should be available 24 by 7, and conflicts can be resolved later. Okay, stale data is acceptable, but the system must be always be available. Okay, and where the user experience matters the most. So where are they used? In social media. And for example, it is fine if your friend sees your correct likes later or views later. A system can resolve those numbers but the app must never to go down. Imagine you're using your social media and app is down. That is not a very good experience. Okay, okay, you can tolerate the little stale information about the views or about your likes, but you cannot tolerate when the system has gone down. Similarly, in your e-commerce application, right, we have product catalog and recommendation. It is okay that you get little stale information about your recommendation, or if your product catalog contains little stale data, that is fine. But the page itself is not loading. That may create a problem. So it should be available 24 by 7, 24 by 7. So this is where we make a choice of availability in social media apps or in the product catalog or in the recommendations. Okay, where little stale information is tolerable. Let's try to understand the same use case using for when we have made a choice of being consistent. So we have CP system. So incorrect data is harmful for business. Okay, where data integrity is important, a double booking or double spending must be prevented. Where data must be corrected all the time. Little bit of availability can be sacrificed, but we cannot compromise on the data where they are used. For example, in the banking applications. Okay, showing incorrect account balance or allowing double withdrawal is unacceptable. Simply unacceptable. Where you are able to tolerate if the app is down for a moment, but it should not show you incorrect account balance. Similarly, in inventory and order management. What, for example, if Amazon sells its last product twice, that could be a big problem. That is where here also data integrity is very important. In booking system, you cannot sell the same ticket twice. For example, in flights and hotel. Here also, consistency of the data is of prime importance. Little bit of availability can be sacrificed here. That is where we make a choice of being a CP system. Okay, so this is a big picture. Okay, for example, in the social media, in the product listing, in the reaction and likes, we can use the AP system, availability and partition tolerance system. In banking system, in inventory and booking reservation, we are using a CP system where the data is very very critical. So this is a list of use cases wherein we use both for AP system and CP system. I think that's it from my side. I hope you like this video.